Alright, so we're starting to get into the meat of the chapter here in 4.3. Again, we've got a quick warm-up. Lots of theorems after this, so get ready. But let's go ahead and try the warm-up first, and pause the video and play it when you're done. Okay, so let's do this. We have, again, a few warm-ups here. Let's get my color. There we go. Number one, we're going to find the measure of the exterior angle, DBA, of triangle BCD. So this is kind of describing a picture here. So what I'm going to do for number one is come up and draw it. I have triangle BCD, so I'm going to draw that B, C, and D. Do like a scalene triangle. I really don't know what kind of triangle we're dealing with, so I'm just going to draw one and just deal with it when we get there. So it says find the measure of exterior angle DBA. So DBA, so we're going to have A out here somewhere, right? If DBC is 30, so let's go DBC is 30 degrees. And measure of angle C is 70 degrees. And measure of angle D is 80 degrees. So first off, we have to know how to draw an exterior angle. Well, if this is our interior angle, the exterior angle is going to be the adjacent angle, and it's going to be the angle that forms a straight line with CD. It's going to be this guy right here. This is our interior, therefore this would be our exterior by default. So this is what I just call X degrees. Those are our exterior angles. This would be A right out here. Now again, the key on this is going to form a straight line. So our angle is going to be, for X, it's going to be 180 minus 80. Our straight line, take away 80, that's going to give me X. So X is 100 degrees. That's my exterior angle. Number two says, what is the complement of an angle with a measure of 17 degrees? Remember, complement is like if I have a right angle, well, one of my angles is 17 degrees. So the complement would be this guy. Remember, all we do is we go 90 minus the angle to find the complement. So 90 minus 17 in this case would be X. So that'd be 80, 70, 73 equals X. And then number three says how many lines can be drawn through N parallel to MP. So here I have to be parallel, which means I can never touch it. So if you think about it, no, there's only really one line you can draw. So it'd have to be that one. So I would say 1, and I would say only one line would never intersect line MP. I'll call it a line. I know it's a segment, but we're talking about lines, and so it must be extending forever in that case. And we're talking about parallel. Okay, so there's your warm-up. Again, just going over a few key words and phrases. One of them is going to be, obviously exterior. We're going to talk about the parallel lines. It's going to be one of our concepts as we go through. And obviously complements. So let's go ahead and get started. Alright, so today what we're going to need to be able to do, so we're going to be able to find the measures of interior and exterior angles of triangles. I just did interior and exterior angle of just a standard triangle, so we've kind of already done that. And you're going to be able to apply theorems. There's a lot of theorems we're going to talk about here about the interior and exterior angles of triangles. So obviously we need to go through those theorems and then apply them. So getting started, we got our triangle sum theorem. So the triangle sum theorem is basically this. I'd mentioned this in the last unit. Any three angles in a triangle, if you add them up, is going to equal 180. So if you look, I think it's the next slide, yeah. This is kind of how you would prove the triangle sum theorem, is using that auxiliary parallel line that we talked about. So if I went back here and I showed this to you, if I drew an auxiliary line, again, if you're asked to prove this theorem, this is how you're going to do it. And I can call these like angles 1, 2, and 3, and I can call this 4 and 5. Well, because of A and AB being a transversal, if these were parallel, I could say angle 1 is congruent to angle 4. Therefore, the measure of angle 1 equals the measure of angle 4. Same thing, alternate interior angles. Angle 3 is congruent to angle 5. So the measure of angle 3 equals the measure of angle 5. And then I can use substitution. I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 because it's a straight line. I can do some substitution. I can say 1 is 4, so measure of angle 4, plus measure of angle 2, plus the measure of angle 5 is also equal to 180. And that is basically my theorem. Okay, so if you're asked to prove that in the homework or on a quiz, I've kind of done it. I just didn't give you all the steps. I kind of walked you through the process though, so you should be able to kind of tackle that proof. So that's kind of what I was just talking about here, the auxiliary line. You can always draw, if you need to do it for a proof, draw one line parallel to AC and set up your proof that way. Alright, so let's go ahead and use that theorem real quick. In this case, we're trying to find the measure of angle MJK. So let's look up here, know how to read our angles. M is this vertice to J to K. So follow, it's hard to see, but hopefully you can see my red pen here. I'm kind of going along that angle, and this is the angle I'm looking for. I'll put two arcs there because I already have one arc on these other ones, and I don't want you to think they actually measure the same. So I'm looking for that angle. Here's what I do know. I do know these two angles with the one arc are congruent. So let's start over here actually, because I have two angles in triangle MNK. So I know that if I took, let's call this guy X. So I took X and I added 88 and 48. Because of the triangle angle sum theorem, I know that would add up to 180 degrees. And that's how we're going to use that theorem to help us solve this problem. So let's figure out what X is. So I have X plus, and that's 88, so 9, 10, 11, 12. So now I'm at 1208 if you add 40, or sorry, 1208, 128. But add 8 more, 128 plus 8 is 136. Okay, so I know X plus 136 is 180, so subtract 136 from both sides. So 36, that's 46, 56, 66, 76 is 40. 4 more is 44 degrees. So I got this angle here is 44. Therefore, this other angle that had the one arc is also 44. With that, I can jump over to this guy. Let's call it Y. And I can find the measure of angle MJK. Because I know that 44 plus 104 plus Y is also 180 degrees. So 144 plus 40 is 144, and 4 more is 148. I'm at 148 plus Y equals 180. And subtract 148 from both sides. So that's 58, 68, 78. So that's 32 degrees. And that's me basically using the triangle angle sum theorem to you know how to apply it to solve the problem. Again, Y, I should say, you know, Y was the representing the measure of angle MJK. Go ahead and put that in there. I just called it Y to set up the equation. Alright, so we have some other proofs here. First off, we have some corollaries. Now, this is the first time you've seen the word corollary, so this would be a new definition for you. So again, a corollary, you want to know what it is first. It's a theorem whose proof follows directly from another theorem. So in other words, they're really closely related. So the first one is the corollary. These are both the corollaries to the triangle sum theorem. So the first one says the acute angles of a right triangle are complementary. And here's kind of what you should know. These three angles add up to 90. So if I did 180 minus 90, sorry, I said that wrong. These three angles add up to 180. So if I took this 90 away, I'm going to be left with 90. So that has to get distributed between these two angles. So again, to see how it's closely related to the triangle sum theorem, so I kind of used it to kind of show the corollary. So again, that's where I kind of get the corollary from. I don't know what D and E are, but I do know if I added them up, I'd get 90. Next is the one I talked to you about in the other lesson. The measure of each angle of an equilateral triangle is 60. So again, we talked about that already in the last unit, so I don't really need to go over it again. But again, you just go x plus x plus x equals 180, right? So anyway, that's going to be 60, 60, and 60. If you wanted to add them up, that'd be 60 plus 60 plus 60 is 180. Okay, so those are two corollaries. You want to know those two. One is something I already talked to you about. One I actually kind of mentioned a little bit. I didn't mention this directly, but I did talk about this concept in 4.2. Alright, so now we're going to go through some more examples using some of these concepts that we just learned. So example 2a says the measure of one of the acute angles in a right triangle, 63.7. So two parts to this problem. One, we have acute angles in a right triangle. So I know the acute angles are going to add up to 90 degrees. So if I look at my talking about the two acute angles, I know they're going to be 90, so I'm going to call one of them x and the other 63.7. I know they add up to 90 degrees. Those are the two acute angles. So here, just subtract 63.7 from both sides. So subtract these. I know 90 minus 60 is 30. 30, that's 29, 28, 27, and then 26.3 degrees. Pretty simple if you know know what property to apply. It's just basic one-step equations from algebra, right? Just know your corollaries, know your theorems and your corollaries. You can set them up pretty easy. Next up, the measure of one of the acute angles in a right triangle is x degrees. What's the measure of the other acute? So this is another one of these situations where I know I'm using that same corollary theorem that my two acute angles are going to add up to 90. So I'm going to go x is one angle. The other one, though, we don't know what it is because we called one x. Well, here's all we really need to know. I know these, if that's x, then this angle is automatically, you can call it y, but here's what I want you to think of it as. How would you get y? Well, I know these two add up to 90. So if this was, let's just say this was, just follow me for a second. If x was 30, then what would y be? Well, y in that case would be 60, right? 60 plus 30. But I can also go 90 minus that angle. 90 minus 30 is x, or is 60. So your equation you can write is 90 minus x. So if that's x, that's 90 minus x. If I called this y, then that'd be 90 minus y. So my equation would look like this. X plus 90 minus x equals 90. That's your equation. Now, again, it's not, if you notice, these would end up canceling, right? And that's what it should do. But it's not asking for the equation. It's just what's the measure of the other acute angle, so that's just 90 minus x. But again, I just want you to see if I added these up, the x's would cancel, I'd get 90 equals 90. It all cancels itself out. But I'm just looking for this guy. They want the other angle. So you just call it 90 minus x degrees. Now you may wonder, where did I do that before? It's the same thing as a complement. That's all it is, just a complement. Okay, and I don't mean by like I'm complimenting you. That's not what I mean. Okay, you should know what I mean. You got your supplements, you got your complements, right? You know the two angles add up to 90. So if you know one angle is x, the other one is 90 minus that angle. Okay, we did that in chapter 1. I did that in a warm-up, and now we're doing it here. Same basic premise. All right, next up, the measure of one of the acute angles in a right triangle is now 48 and 2/5. What's the measure of the other? So we've been doing this already, 2 examples in the books. We'll do one more. Here, though, just kind of understand that's 48 and then 2/5. You should know this, but if you don't, 2/5, if you made it over 10, if I multiply them by 2, this would be the same as 4/10. So you can go 0.4, 48.4 for that first angle. So I know 48.4 plus x equals 90 using that triangle corollary theorem, triangle sum corollary theorem. So you're just going to subtract, in this case, 48.4 from both sides. In this case, I got x equals, I know 90 minus 45 is 45, that's half of 90. Then I have 3.4 more, so 44, 43, 42, and then that's going to be 41 then, 0.6 degrees. And there is your complement, right? But it's your second acute angle. Okay, so now talking about those exteriors, I kind of mentioned it in the warm-up. If you didn't know what that exterior kind of meant here, here's another picture of it. When you're talking about exterior angles and interior angles, now obviously when you have a triangle, you have your 3 angles inside the triangle. Inside, interior, okay? The exterior, though, here's what you got to understand. The exterior, when you're talking about points, it's all the points on the outside. But if you're talking about an exterior angle, it has to, it's going to form a line with an interior angle. You need to write that down so you know how to set up an exterior angle. Okay. Give you an example what is not an exterior angle. So if I had a triangle and we did this, so I extended both these sides, and I had 1, 2, and 3. Angle 1 and angle 3 are not I'm saying that wrong, sorry. I'll fix it. Angle 3 is not an exterior angle. To angle 1. Instead, it is a vertical angle. To angle 1. Again, in this case, the exterior angle would be angle 2. This is your exterior angle. This is the exterior angle to angle 1. So again, it has to form a straight line. The one that's across from it, that's not an exterior angle, it's a vertical angle. It's another type of angle, okay, basically. Vertical angles, you should know, are congruent, but exterior angles are supplementary with the interior angle that it's adjacent to, okay? So that's, again, important notes to get from that. Okay, so I already kind of talked about that, so here we go. Kind of went over all this. There we go. Bam, finally. Okay, so there's a theorem attached to exterior angles, so we have that picture, so let's kind of talk about the theorem. This is one we're going to use a lot, more algebraically than anything else. Not as much in the proofs. We will use them in the proofs, but this is used algebraically quite a bit. So what it states here is that the exterior angle, any exterior angle to a triangle, is equal to the sum of the two this is the way I word it, the two non-adjacent interior angles. You'll see I have this angle 4. Now, the adjacent interior is 3. Get rid of that, and let's compare it to 2 and 1. That's what they're doing here. The sum of the two non-adjacent interior angles equals the exterior angle. Think of it this way if you're doing the proof. 3 and 4 add up to 180. Okay. Well, so if you think about that, so 3 plus 4 is 180. Let's kind of write it out. The measure of angle 3 plus the measure of angle 4 equals 180. Well, the measure of angle 3 plus the measure of angle 1 plus the measure of angle 2 also equals 180. Well, can I just do a little bit of substitution then? Don't those equal that? If you think about it, right? You'd be able to set these two equations equal to each other, and just subtract the measure of angle 3 from both sides. They'll cancel each other out, and you'll be left with this equation. There's your proof. It's a non-formal proof. I make it non-formal because, again, that means I can ask you to do it on a quiz or in your homework. If I don't ask you in your homework, guess what? You're probably going to see it on a quiz. So make sure you pay attention to the steps that I'm giving you because I'm mostly wording it out. Alright, so let's use it. Might as well use this thing that we just learned it, right? So example 3 here, we're going to find the measure of ACD. Now you notice ACD is an exterior angle. It's adjacent to ACB. But again, remember, this is, this is my exterior, it's 6Z minus 9. Now it's going to equal my two non-adjacent interior angles, which is this angle right here, which is a right angle, and this angle right here. So these two are going to be equal to my exterior. So it's going to equal 90 plus 2Z plus 1. So just a little bit of algebra. If you can use the theorem to set up your equation, you just got to do algebra from this point. So this would be 91 plus 2Z. So let's do some math. Let's subtract 2Z from both sides. So that's 4Z. While I'm at it, let's add 9 to both sides. So 4Z equals 100. Again, just doing algebra, let's divide both sides by 4. And Z is 25. Not 25 degrees though. So make sure we're answering the question. They're asking you to find the measure of ACD. So I want to find this measure. Again, I don't want to word it that way. I want to show you. I'm going to take that 25, plug it right in there. So let's do it. So this is going to be 6 times 25 minus 9. So that would be 150 minus 9, so 141, which makes sense. Looks like it's an obtuse angle if it was drawn scale. I'm assuming it is. So I got 141 degrees. Okay, just using the theorems. You know the theorems, and you can set up these equations easily because it makes sense. I'm just doing what the theorem says. All right, now we got another theorem. So there's a lot of theorems here. We got our third angles theorem. So this is not a corollary or anything. It says two angles of one triangle are congruent to two angles of another. Then the third pair of angles are also congruent. Here's what that's saying. See here, I got two triangles that have two sets of congruent angles. Well, I got a third angle in both of these triangles as well. So that is going to be congruent to that. Again, if this is X and Y, then that would be X and Y. And I know X plus Y plus Z equals 180. Over here I know X plus Y plus, I don't know, call it L, equals 180. If you subtract X, X plus Y from both sides, those cancel. I do it over here. Same thing over here, minus X plus Y. You'll see that I get Z equals that, and I get L equals that. And so if those are equal to the same thing, Z equals L. Which kind of should give you some non-formal proofs so you can get an idea of how to prove this if I asked you to do it later on, or in homework or quiz or whatnot, right? So again, if you know the theorem, then you got to apply it. That's all you got to do. So let's find the measure of P and T. Well, see, I have two angles that are the same, so that I know these angles are equal to each other. So set them equal. That's all we're doing. So 2x squared equals 4x squared minus 32. So let's solve this. Let's start by subtracting 2x squared from both sides. And let's also try not to freak out when we do it. It's like, what do I do? Oh my gosh, these canceled. It's 0. Calm down. It's 0. You gotta put something there. Don't put nothing there. I mean, I am putting nothing there. Just write 0. That's nothing. But put a number. Alright, anyway, so that's going to be 2x squared minus 32. And then let's keep solving. I'm going to add 32 to both sides. I'm trying to isolate that x. So 32 equals 2x squared. Again, let's isolate the x. Let's divide by 2. 16 is x squared. Hopefully you remember how to get rid of a square. You square root both sides. And technically, x is plus or minus 4. I mean, it really is. They want you to find the measure of the angle, so actually it doesn't matter what you plug in for negative 4. I'll use 4. I figure that's probably better. So I'm going to go 2 times 4 squared, which is 2 times 16, which is 32 degrees. Do it down here, double check we did the math right. 4 times 4 squared minus 32. So this would be 4 times 16, which is 64, minus 32, which, guess what? 32 degrees. We did it right. Yay. So that's all we're doing. Know the theorems, plug in the equations. All right, so with that, we are kind of wrapping this up. We got a lesson quiz here. Just getting to clarify this. Number 1 is just like the example we did. So make sure you understand the corollary theorems for number 1. Number 2, looks like we're using, we have an exterior angle, so make sure you understand that theorem and the equations we set up for the exterior angles problems. Hint, hint. Number 3, find the measure of n and p. Again, just we're applying the theorems step by step by step. These are almost exactly like the questions in the notes. So if you go back and use those as your examples, you should be able to ace these quizzes, okay? And then part 2, just got an application, but look at the picture. It should kind of clarify what we're trying to do, okay? So again, the diagram is a map showing John's house, Kay's house, and the grocery store. What is the angle the two houses make with the store? So we have the two houses. Here's this house, there's this house. We see this line here, this line here. So you got the angle for the store. We need to find that angle, okay? You should be able to set that up using the theorems we use in this chapter. And with that, do your lesson quiz, do your reflection, and I'll see you guys in class.